Bene, direi allora che possiamo cominciare.
Okay, then, without further ado, I think we can start the ball rolling. Ladies and gentlemen, welcome to this new webinar from Ocrim. Today, we will be talking about dosing systems for macro and macro ingredients. This will be led by Fabio Vuoto, the technical director in Ocrim. My name is Anna Buffa. I am a food trainer, and I've been taking care of food, issues for years. So I will be here with you today. We will walk
Qualche
you through
parola
this very interesting subject. Just a couple of words on how we will manage the webinar. It will take around 60 minutes or so. We will be done by 5 p.m. now, 5 p.m. Italian time.
Ci potremo confrontare rispetto a
Now,
quanto.
it will be possible to, share information and to have a feedback after the end of Fabio's presentation. There would be a couple of Q&As. The first one after around 30 minutes, and then the second one at the end of the presentation. Now, questions are anonymous, so please share with us all what you want to share, depending on the topics we will be dealing with together. Now, if you have, a little bit complex questions, no worry. You will send an email to, as you can see here, conferenceroom@ocrim.com. So within 24 hours, we will send the answers, let's say customized answers to all of your questions. Now, today's meeting, as I said before, concerns dosing systems for macro and micro ingredients. Our main aim will be to walk you through briefly the equipment solutions and the tools built by Ocrim, so mills, but also many other dosing systems to dose the ingredients we will add into flours. So once again, there's a big market in this. Now, once again, Fabio Vuoto will be talking about macro and micro ingredients. Fabio is our technical director. You can see the bio of Fabio here. Fabio joined Ocrim in 1985. He was a junior mill designer. For 10 years, he worked in Minneapolis, in Minnesota, in the US. And then he came back to Italy in 2006. He was deputy director Ocrim Plant Engineering Department. And in 2018, 3 years ago, he became our technical director. Okay, this is it. So the floor goes now to Fabio. Once again, don't forget to send us questions and comments in the specific box. Just click on the bottom of your screen. Now, good morning or good afternoon, everyone. So thank you so much for being here with us from the other side of the ocean, and welcome to this webinar on dosage systems for micro and macro ingredients. So why did we decide, to organize this webinar? Well, it's because Ocrim thinks it is really important to give information and insights, you, customers, and stakeholders onto the evolution of flour markets. Now, we're doing this because, of course, we want to meet the new needs of today's consumers or today's customers. Of course, I'm talking about, let's say, the small, medium, but also large customers or industries. So we are doing this because basically, as you know, the mature markets require more and more often the availability of products which are ready to use. So ready to use the pre-mixed products, pre-mixed and even pre-packaged, containing all of the ingredients that which is what you need for your, traditional, classic, or even innovative recipes. Of course, recipes can be updated and they change constantly. We would like to create, ready-to-use flours. You may want to make pizza or maybe cakes or once again sweets in general, or if you will, homemade pasta. So I will tell you how to use these ready-to-use products. Now, this is for the large retailers. So, for example, the supermarkets, but also in terms of supplying the industries of the food sector, because of course what they do is processing ingredients to make end products. Now, to make the ready-to-use flours, so you can start from the so-called primary flours. And in this case, you will just add some ingredients during the milling, so right into the mill. You also have an option, an alternative. So you may want to create a more comprehensive plants or equipment with flowers. I mean, you can have different varieties of flowers plus adding ingredients in complex systems, which usually are made into the storage silos where basically we process, the products. So for example, the mills, flour, storage silos. Now, in both cases, if you really want to make finished products, you have to add ingredients to the basic or primary flours or basic materials. Of course, I'm talking about different qualities or different types of flours. Now, to do so, the ingredients we will add are, let's say, split into two different types, so two, categories. As you can see here, we have the so-called macro ingredients and the micro ingredients. Now, there's a key difference between macro and micro. Of course, it depends on the quantity of ingredients that we will be adding to the flour. I will be talking about percent, so percent rates. So, for example, when we say macro ingredients, that you can see here in bullet number 1, the quantity of additive is more than 1% of the total final product. We're talking about micro ingredient, where the quantity of additive to be added to the main flow is less than 1%. Now, this means that, the storage bin size will change. For example, in terms of macro ingredients, we have the bins. So bins, will be bigger than the micro ingredients. I mean, from 500 liters up to some thousands of liters. So in this very case, so we can store from 250 up to 1,000, 1,250 kilos of products. In some cases, even more than this. In terms of micro ingredients, of course, the quantity of product to be added to the main flow is much smaller. So the bin here, the bin size is much smaller. I mean, from 50 liters up to 100 or 150 liters. So basically from 25 kilos up to, let's say, 50, maybe up to 75 kilos of additive. So in terms of macro ingredients that we are using in order to create the so-called ready-to-use product, well, this is what you can see here in the circle. Basically, we have gluten, enzymes, salt, sugar, and we also have many different kinds of pre-mixes. Now, these blends contain many different types of products. Of course, it all depends on the recipes from the end customer. Now, for example, if you want to make a product, ready to use for the let's say, industries making biscuits or cakes, you will add sugar. If your customer is a customer making pizza or bread, so a baking industry, in this case, we would add salt. There are many other macro ingredients, as I said before. So we have enzymes and the so-called pre-mixes, blends which are represented by yeasts and other products which are usually used, if you will, to improve, let's say, the performances or the features of flour so that it becomes a ready to use flour, just to make the final or end product. So back to macro ingredients. We also call them zonals. When we use this word, the zonals, now this means that they come from a specific zone or area. So it depends on the the target you have. So the zone, as we say, of the market. They may also be represented by other cereals or flours from other cereals. For example, today, very commonly we use ready-to-use product with different types of blends. For example, wheat, spelt, and beans. We're also working on adding, legumes, flours, and in order to make this product. And once again, these products are the so-called ready-to-use products. Now, this can be sort of, over-the-counter products, so the typical supermarket product. This is what you can find on the shelves. So this is what basically are used by non-professionals. I mean, people who really want to, prepare some, food at home. But at the same time, we also have some special recipes that have been specially made for the food industry because, of course, we have to comply with some, specific specifications. So with those systems, you can really, really make every kind of end product. Now, as for dosing macro ingredients, we have a couple of possibilities that you can see here. We have the batch system. Once again, the system is based on batches. Now, this means that the additive is weighed individually and out of the main flow. And it will then be, let's say, merged into the main flow separately. You also have another option, the so-called loss in weight system. Now, this means that we have a continuous, uninterrupted, dosing. You have to verify, all the time how much macro ingredients I am, adding to the main flow. And you can do this with, once again, the so-called system on what the name is loss in weight, or we say loading cells in Italian. Now, this means that basically we position, the bin that contains the macro ingredients onto a scale. And now this means that if you empty the scale at a specific speed, so because the weight will become smaller and smaller, so we will control the weight reduction. This means we will add or reach the quantity that was pre-established, so that you have the right quantity of additive in the main flow. There's a difference, of course, between batch systems and loss in weight system. Now, the difference is the following. At the same time, I may add more than one product to the flow because, as I said before, every single additive, every product is weighted individually. In the batch system, I have just one single scale, which is, let's say, loaded with different ingredients. The volumetric system, we will be talking about this later, is rarely, seldom used with macro ingredients because it is not effective. I mean, it is not really able to control the quantity of product which is added. I think there's an advantage, as I said before, of the addition of macro ingredients in the gravimetric system, is that we can add more than one ingredient at the same time. So during the design phase of a specific macro ingredient dosing system, you have to consider, let's say some key parameters that you can see here. Depending on them, we will be able to correctly design the system. Now, these numbers, the macro numbers that you can see here, are representing the quantity of product as a percent rate to be added. So it determines, if you will, the capacity of the dosing system, the precision of the dosing system, the number of components into the recipe. So this is one of the most important factors. And based on this, which is basically depending on the needs of customers, it also depends on the conditions, the equipment that you have in order to design the complete mill. So based on this, we will be able to make the most, the best choice, and it will create, the best system for the addition of ingredients. As for the micro ingredients, now the dosage here is much more accurate, if you will. So a much more accurate dosing, because of course we're not talking about quantities to be added to the main flows. Now this is really a minimum, very very small quantity. As you can see here, it's vitamins or enzymes or improvers, for example, the ascorbic acid, which are added in very very small quantities. So once again, what is really really important here is the precision and the accuracy of the dosing action. because again, here we are adding very small quantities of products in terms of grams, just some grams for every ton. So the unit of measurement here is ppm, so parts per million. In this case, the dosing system has to be very, very accurate because what we add is really so small versus the total amount of product that will receive the additive. Okay, then I think we can stop for a second and we can now, well, answer some questions, if any.
Con le prime domande.
Okay, let me start with the very first questions that we have received. The very first one concerns, of course, macro ingredients. The question is, even if in small quantities, these macro ingredients mixed with flour may, stop the gears, I mean, the mechanics, if you will, of the machine. Is this a possibility? Well, you have to consider that these ingredients are really very, very sensitive to the atmospheric and environmental conditions. So these products are usually powder products, very hygroscopic. So they are really impacted by humidity and temperature. So you have to have, well, you really have to be very careful in designing the right bin or the right container in terms of shape and material so that the product doesn't stick to the walls so that it can, freely flow without stopping, in the pipes. Now, these are once again powdery materials, and again, they may, sort of create clots. Now, clots may once again obstruct the dosing system. So the dosing systems, but also the boxes or the bins that contain, marked ingredients, they have to be equipped with a specific device. It is basically a stirring or an agitator. Once again, a stirring device breaking, the granules or the clots so that there's always some movement. This means that the product will not become too compact, too, hard, because in this case, some sediments may accumulate on the pipes. Once again, the bin, but also the dosage systems are usually made in stainless steel. And well, of course, they have to guarantee the highest level of sanitation. They are also treated with Teflon. So Tefloning allows the product to flow in a better way. This means that even if you add very small quantities, they do not obstruct the dosing system. And usually this is made by a screw dosing system. So basically, there's once again the so-called endless screw suction system. It can be made in many different materials, many different forms, because of course we wanted to adapt at best at the handling. So let's say the maneuverability, if you will, of the macro ingredients. So we have those systems with a screw made in stainless steel. In other cases, we have Teflon, steel, and in some cases, we have other dosage systems made in synthetic materials, for example, polyethylene. And all of this is food grade, so food compatible. Once again, all of this has been specially conceived because we want to make sure there is no, let's say, clotting or stopping the machine. Um, and again, also the self-sanitation, so the self-cleaning of the system has to be guaranteed. Once again, the operation is so accurate, there's no product, left inside the dosing unit. Don't forget that all of this is done not just with the use of special materials. So we are now, let's say, selecting all of these systems based on the type of product that has to be processed and dealt with. At the same time, very carefully, We take care of the design, but also the execution of those systems in terms of tolerance management. When I say tolerance, I mean the empty spaces we have between those tool on the one side and the second part of the system containing, I mean, the product. Now, if there's a big space between the pipe and the rest of the mechanical components is too big, there may be some sediments. I mean, there may be some product there. If this space is very small, of course, it's impossible for the product, I mean, to remain inside the piping. Now, you also have to well, to go back to what you said before. So we have to make sure the machine doesn't stop. This may happen unless you take into account the factors I have just mentioned. I mean, the compatibility of the dosing tool on the one side and the ingredient to be dosed. Every single ingredient is unique and has different features. Of course, sugar is different than salt. When it is manipulated, with these mechanical tools, it behaves in a different way. The same goes for gluten, as compared to enzymes, amino acids, or ascorbic acid. So once again, you have to be familiar with the product and you have to really, really perfectly know how to deal with this. It's incredible. I mean, humidity has a key role in this. Yes, it has a very big impact. For example, when we purchase raw materials, we always have to be careful enough. You have to verify to measure the, let's say, initial humidity level, declared by the seller, and you have to keep these products in, well, dry environments where, I mean, humidity and temperature are kept under control. Um, for example, the storage rooms of macro and micro ingredients are usually temperature controlled and with air conditioning. I mean, there's a specific, automatic conditioning system because also, in the warehouse, so we have to have the right conditions again, so that the product, doesn't stick and no, clots are produced. So from the hygroscopic point of view, it has to be constant or consistent. Okay, I have a second question before you move on to the second part of the presentation. The question is,
micro e dei macro ingredienti.
so how much time do you need for the mix? I mean, to make the mix, macro or micro ingredients? Now, it depends on the type of mix. I mean, if you have a traditional batch system, let's say that if you have a batch mixer, well, let's say it takes 30 to 40 seconds. If the number of ingredients to be added to the main product is maybe three, four, maybe a maximum of five ingredients, well, let's say that the time required is from 30 to 40 seconds. In this case, you get a mixing level that's, let's say, complying. Well, of course, we do have some specific tables where you can see the compliance level of every single mixer. Basically, we take a sample in different parts of the mixer, so we carry out a lab analysis, and we can make sure whether or not the samples do contain the percent rates of ingredients that have been added to the recipe. There are some specific parameters that define the quality of the mixing. If you really want to reach the right approved, mixing level approved by regulations or in compliance with regulations, if you have good mixers and good dosing systems, it takes from 30 to 40 seconds to get excellent, levels of mixing. Okay, this is the batch system mix. Now, in terms of the continuous mix, once again, it depends on the number of ingredients you want to add. In this case, you may want to add more ingredients at the same time, but we never have to add more than two. Maybe the maximum is three, because also in this case, it takes from 15 to 30 seconds. Let's say more or less 10 seconds per ingredient if you really want to have the right complying mixing level. Okay, sounds perfect. You've been really, really very exhaustive, very clear. So I think you can continue with the second part of your presentation, and then I'll be back in around 30 minutes for the second Q&A session. Thank you. Okay, then. So we have analyzed, if you will, the types of ingredients to be added, to flowers in order to make ready-to-make products. Now, I will briefly walk you through the analysis of the systems. So the addition systems, I mean, the systems that you can count on to add macro and micro ingredients. Basically, we have three different systems that help us add ingredients to the recipe. We have the volumetric system, the gravimetric system, and the batch system, which once again we have talked about before. So once again, these three systems, volumetric, gravimetric, and batch, let's say this sequence also represents the level of efficiency. The volumetric is the least effective, followed by the gravimetric system, and then we have to say that the best system is the batch system, which in our opinion is the most accurate, dependable, and reliable in terms of managing the dosing of macro and micro ingredients. The volumetric system that you can see here is the one which is commonly used. Well, let me rephrase this. We used to use it some years ago. Now we use it less and less often, or more and more seldom. Now we use it in the mill. In those cases where you want to add, the macro or macro ingredients directly onto the mechanical system that collects the final product. For example, the flour collection screw or the chain conveyor belt. Now, this system is represented by a bin inside which we have the ingredients that you want to add. So thanks to the dosing screw or the dosing system, it can be a screw, but also the so-called cup-based system. Depending on the volume or depending on the revolutions made by the dosing system, the system is able to transfer, so to display a specific volume from the ingredient bin to the bin, which collects the main flow. So if you are able to increase or decrease the number of revolutions, so you have either an increase or a decrease, which is proportional, of course, and I'm talking about the quantity of additive or product that has to be added to the main flow. So what do you get? Well, so you can have quite, reliable dosing system, but at the same time, this system very much depends on the influence of the climate conditions, as we said before. These conditions may have an impact on the product. The product may change its specific weight because it is a volumetric system. We don't have the precise, accurate perception of how many grams or kilos of product we are adding to the main flow. So, I have to say that this system has, of course, some pluses or pros, but as you can see here, this system has quite a long number of cons or drawbacks. As for the main, pros, this is, of course, it's an easy to install system, and the system is really cheap. There are plenty of drawbacks that you can see here on the right-hand side of the slide. So we have to say that the accuracy of the dosing is not very high because once again the quantity of product being dosed is subject to the variations of the specific weights of the product that I am using as an additive. So this requires a constant adjustment of the dosing speed that has to be adjusted, because as soon as you change the product, of course you have to accordingly modify the system that speeds up or slows down the dosing so as to have an acceptable outcome. Now, this system, as I said before, is not able to quantify the grams of the kilos of product to be added. So we usually cannot make any report in terms of the quantity of additive that's been added. This means it's very difficult to have a specific traceability of the end product. And the system is quite simple from the electromechanical point of view because it has a minimum level, so a threshold telling me that the product I am dosing is about to be, let's say, it's about to be over, so it will be depleted soon. But we have no other system. So again, this technology cannot be managed remotely, um, and as a consequence, this system is not used very often, especially in the top level, highly automated plants, which is what we have today, because once again, as I told you, this system requires a very frequent dose adjustments. Okay, this is the second system, whose name is gravimetric system. Now, this system is based on loss in weight as so as to determine the flow of the material that I want to add, so the additive. Well, usually this system is used in the continuous mixer systems where it feeds the continuous mixer. So in the mill, this system can be used, and actually it is used more and more often today, well, especially on the well, a mechanical transport system in order to collect the end product. Now, this is gravimetric, so basically and effectively it controls how much product I am adding. Well, this gives you a key possibility. So we have the possibility to manage this automatically by, if you will, connecting the dosing data on the one side to the centralized control system on the other, measuring the product that leaves the mixing and milling part of the machine. So steadily, at all times and automatically, this quantity can be updated in terms of the dosing speed by keeping the percent rate of ingredient to be added constant and steady. Let me rephrase this to be clearer. At the end of the milling phase, so at the end of the main screw or the cup conveyor belt, we have a control scale. The control scale tells you exactly how much flour I am extracting. Now, if my recipe, includes 2% of such an ingredient or additive, I know I am making a certain number of tons of products an hour with, for example, 2% of additive. Now, this 2% is calculated automatically and the right quantity, so exactly 2% of additive is governed and managed constantly thanks to the automatic system that acts on the inverter or frequency converter. Now, the inverter manages or drives the dosing unit so that you can either increase or decrease the number of revolutions. As a consequence of that, an increase or decrease of the quantity of product to be added so that the quantity or the percent quantity can be kept, over time. This is what I need to add to the main flow. So once again, these are the advantages of the system. There's a very high dosing precision. The system is easily integrated in highly or heavily automated systems. This means that we are able to guarantee the right traceability. At the same time, as I said before, the system is easily integrated with the plant alarm system. You also have the possibility to release reports, which are very reliable on the exact quantity of product that has been added to the main flow. Now, this system is highly recommended for the production of big batches, just with a few qualities. Now, if I launch a production that lasts for some hours, well, This is, of course, in my opinion, the best system because there's no changeover. So, well, I have to set up the plant in order to produce a specific quantity of product in a specific number of hours. So once again, where there are no changes, no changeovers, I mean, I don't have to have a very flexible machine. Possibly this is the system I recommend because it guarantees the best ratio between investment on the one side and the return on investments on the other. Let me now move on to the third system, which, as I said before, is the most flexible one. And again, as I said before, this is the batch system. Now, the batch system offers, in my opinion, the best precision ever. Also, and especially when you have to make small batches, which are very different, from each other. Again, the batch system. Now, basically, this is a small mixing system, if you will, because by so doing, we have the possibility to do the following. So we have the possibility to dose very accurately, very precisely, and we do this with a so-called cumulative scale. So we weigh every single ingredient one at a time. Then, eventually, all of the content we have on the scale, so macro or micro ingredients, will be merged into the main flow. Usually, we do this in a mix-up, of course, together with the basic product, so as to make the final end product. There's a big advantage represented by this system. Um, well, basically, it gives you a very high level of accuracy, as I said before, top flexibility, again, because by this I mean that, there are plenty of changeovers possible. I may have a different recipe in every single batch. So this is, a dosage system for macro and micro ingredients, which in my opinion is the most effective one that you can find on the market. This is exactly the system which is used in the pharmaceutical industry. Now, of course, in the pharmaceutical industry, quantities are much smaller, and the dose may be sometimes very very small. Because in that case, of course, we're talking about milligrams, so thousands of grams. Anyway, this system has been borrowed by the pharmaceutical industry, so this system gives us the best, flexibility and the best precision possible. There is more because when it is applied into a plant with a high level of automation, well, you know that today almost every single mill is highly automated. So there's a high level of automation in almost every system. This means we are able to deliver best results and reaching at the same time the best flexibility ever. This is the system I recommend for those of you who have to produce many different batches belonging to many different recipes. For example, if in the same day you have to produce a batch of product for customer A, then you have to produce the other batches for customer B and then customer C. Well, this is the best system because, as I said before, this is the most flexible one. It offers you exactly the same accuracy and precision every time you change the recipe. The gravimetric system is not able to do this because when you do the recipe changeover, the gravimetric system, I mean, for just couple of seconds or just for some instance, it's not able to weigh, so it works in volumetric terms. So every time there's a recipe changeover, the gravimetric system shows some issues. The batch system, when the recipe changes, is the only one able to guarantee the highest precision and accuracy level ever. Now, the batch system is also able to make plenty of different reports. You can do all of the traceability you want. You can also, control it remotely with the so-called automatic recipe launcher and the automatic planning launch. So I have to say that once again, this system, the badge system, in my opinion, is the most complex one, but at the same time, it is the most flexible one, and it requires, I mean, the largest investments.
Analizziamo un attimo quello che è il discorso relativo
So
invece.
let's Let's analyze now the part of the presentation on bins and how to load bins in terms of macro and micro ingredients concerning those systems. Now, traditionally, I have to say that these bins are loaded manually. So basically, from the room where they are stored. So in this warehouse, we have the micro ingredients bags. The operator will take the quantity to use in order to fill the bin, and manually he or she fills the bin, possibly using the same bin for that type of ingredient to avoid cross-contamination. Once again, we do this in order to make sure that possible residues of product batches in that bin may be contaminated by another product. Now, because we want to make more and more automatic systems, some years ago we started using loading systems which are under pressure in terms of suction, but also, so once again, pneumatic system. So once again, pressure or suction. So when we started using this kind of equipment for this very special function, we found, if you will, the presence of some residues of product inside the piping or inside, the conveyors, but also in the, means of transport that we used to use. So for a while, many customers just preferred the traditional system, which is the manual system. Now, because or thanks to the evolution of pneumatic systems, I mean both under pressure, or with a suction system, especially in the past 25 years, today we can offer pneumatic systems which are self-cleaning. Now, basically, this means that there is no residue of product inside the pneumatic system. So once again, this means that there's no cross-contamination, or as we say, pollution between different products in the transport system. When you finish loading one bin and then you load another bin with a different product. This is what people feared until some years ago, and this was the reason why they preferred the manual system to load the bins. Well, I have to say that today we use the so-called pressure or pressurized transport system. So in different so-called phases, so we also have the suction possibility because basically, there is no residual product inside the transport piping. So let me tell you in detail what Ocrim does in order to dose the macro and the micro ingredients. So Ocrim makes these dosing stations for macro and micro ingredients. It can be single or multiple. It can be volumetric, but also gravimetric, as we said before, or as I just said, batch based. Now, when I talk about volumetric system, I have to position the dosing unit, and you can see an example here. So this is supported by a basement. In this case, you use the dosing units, for example, on a flour collecting cup. So this is a volumetric dosing system. This can also be installed onto a scale, so it would be gravimetric, or as you can see here, this is a batch system because all the dosing units are supported by a scale which is located right at the center of this station. This is a micro ingredient dosing station because the boxes here or the bins are really very small. And what you see under the bins, so you can see here the stainless steel system. This is the dosing system. As I said before, to make sure the product flows consistently with no compacting action, there is a stirring system which is specially motorized. I mean, there's a motor that you can see on the top part of the dosing unit. The lower part of the dosing unit, this is the real proper doser, and it is once again equipped with another reducer. It is driven by the inverter. So it extracts and doses the product. So in a gravimetric or in a volumetric way, if you have a scale, or by batches, which is what you can see here, because once again, there's a scale right at the center of the system. Now, the dosing capacity goes from 0.37 liters an hour up to 5,800 liters an hour in the volumetric systems. So if you think of a specific weight, which may be 500 kilos per cubic meter, this is 185 grams up to 2.9 million grams, or basically, 2,900 kilos an hour. Now, this system, if it is equipped with a scale, which is what you will see right now, here we go. So this is the scale, and you can see that we have basically 4 different scales. Now, the first 2 scales, the first one is from 2 to 10 kilos, the second one from 10 to 20 kilos. Basically, they are the right sizes in order to dose the microingredients by batches. The third and the fourth one, so 50 kilos and 100 kilos, scales are for the dosing of macro ingredients. This is a standalone machine. Now, this machine can also be installed into already existing mixing systems. So basically, what you have to do is to select the type of scale, depending on the precision level that you want to reach. Considering that we are now able to guarantee a system accuracy of 0.2%. So this kind of machine is made with a minimum of 3 up to a maximum of 9 units. So minimum 3, maximum 9. As you can see here in the last line, we also made some special machines with up to 12 dosing units. Now, the individual dosing unit, which is installed onto the flour collection screw, is the same equipment, but instead of being installed onto this machine, it is individually installed onto the flour collecting screw. As I said before, it can also be installed in those systems where we already have the flour mix. And, by fault, we can, load the bin if you have enough room. Otherwise, you can do this in the warehouse or, for example, in the room where we keep the macro and micro ingredients. Then you have a pressurized transporter, the so-called thick phase, flying phase, or suction phase. So you have different systems so as to pick the quantity from the scale, which is then brought to the mixer. So, in a nutshell, this is what Ocrim makes in order to dose macro and micro ingredients. Okay, then, Fabio, once again, that was really, really very clear and accurate. So back to questions. Now, this question is a sort of a summary, if you will, of all what you've shared to us. The question is, so there are 3 different dosing systems. What is the one you really recommend and why? Well, as I said before, I don't think there's just one single, best or, perfect system, because of course, the system is always based or depending on the needs of customers. Now, I have presented you with these 3 systems, and the 3 of them have pros and cons. It depends very much on the need of customers. So this is a very easy example, but I think this is really easy to understand. For example, if you have a mill and the mill needs to produce large quantities of the same flour, and because of course, you have to guarantee the right traceability, accuracy of the dose. So the system may do. So, for example, if you change the recipe just once a day, or maybe once or maybe twice a week, for example, the gravimetric system is what you need. If, for instance, you have a different type of customer. So, for example, you have a mill that needs to change the production 3, 4, 5 times a day. The gravimetric system will present some cons or remarkable disadvantages because, as I said before, it is less flexible. In this case, the best system for a mill that has to produce 4 or 5 recipes a day, well, I would recommend the batch system, so the system which is based on batches. Now, for those of you who just have to add micro ingredients on the primary flours, so in this case, you don't have the flour mixing system, the volumetric system may be more than enough. It's easy, it's cheap. Um, we know that it is not very automatic, it is very much manual. The gravimetric dosing system can also, let's say, depend onto the automatic control system so that you can really control production. Basically, the final product or end product control, scale. So you have the closed loop system. Thanks to the closed loop, you may adjust and adapt the quantity of the um, you know, additive so that production is steady and consistent. I have to say that the best system giving you top flexibility but also giving you top precision is, of course, the batch system. But maybe it is not the real recommendation considering the needs of the equipment. So it depends on the type of investment that you want to make. So once again, from the, those who offer this kind of dosing system, but also in terms of the designers, of course, you have to work with the customer so as to really understand the needs of customers. This means, of course, that we will be able to be as professional as possible. And again, we will meet customers' needs so as to have happy customers. I mean, I'm not going to offer a batch system to the mill that produces, the same flour for maybe the entire week. So if they have to do some mixes, of course, the gravimetric system is much better. Or for example, the mill that produces, the same flour for the entire week, but on the contrary, if you have another mill where they change the bin every single hour, because, for example, they ship products to 15 different customers a day, of course, they have to have a batch system. So once again, I really want to be clear in this case that everything depends exactly and directly on the needs of customers. Thank you so much, Fabio. We have so many questions. So, okay, please be very brief in answering because we just have a couple of minutes. Then we will send out the answers via email. What is the mix ratio that you have in the Ocrim mixer? Now, the Ocrim mixers have a guaranteed efficiency degree of 0.1 per 1,000 or 0.01%. Now, this means that the mixing effectiveness is one of the highest on the market. We use the two different types of a mixer with just one single shovel, as we say, or double shovel. This means that we are able to make mixes and flours in those cases where we have plenty of room available, but also in those cases where we have small space available. Now, the mix ratio is very high. We are, one of the makers of the best mixers on today's market. What is the minimum time? Okay, sorry, the question just disappeared. Just wait me 1 second. What is the minimum mixing time in order to reach the best mixing ratio? As I said before, if you have a double shovel, you obtain this level after 30 or 35 seconds. If you just have the mixer with just one single shovel or one Okay, nice. We have to wait for twice as much. So 1 minute up to 70 seconds. If you have, I mean, two stirring systems or two, let's say, shovels, we are able to reach the optimal, CV, which is for us the mixing ratio. Once again, it depends on the number of ingredients you have in the same recipe. This is the right example for a recipe with 4 or 5 ingredients, okay?
Benissimo, passiamo allora all'ultima proprio domanda, poi
Okay,
chiuderemo
this
con
is our last question for today. Once again,
spero di non
these questions are asked in Spanish, okay? So I hope I won't make any mistake.
vorrebbero implementare
Which solutions can be implemented in the mill with plenty of vibrations in the ingredient dosing area? You said vibration, right? Yes. Well, if you have, remarkable vibrations, it means that the macro and micro dosing system, of course, has to be installed right there. Well, of course, you have to have dampeners. Dampeners, I mean, just, on the system you've just seen. Um, this is also another suggestion I'd like to have with you. You can put it in a different area, and you may want to use a pneumatic transporter so that you can move, I mean, the batch or the flowers, I mean, macro or micro, from that position to the mixer. Vibrations is the most, let's say, harmful, situation for dosing system because they have a major impact. They really, really influence the weight data acquisition, from the, by the loading bin, which is, of course, verifying the weight that I am handling or manipulating. So once again, dampeners, and which is what you have to put, under the dosing station. That's for sure, and this is the, most important thing to do. If you're not able to obtain the result you want, well, you have to bring the micro ingredient dosing station somewhere else. Okay, we have just 30 seconds for the last question. What about the continuous Ocrim mixer? Now, the continuous mixer, no, we don't make it. I mean, Ocrim only makes the batch, mixer. The continuous mixer is made by our partner, La Fragola. Now, La Fragola is a company that makes machines for the feed industry. Now, the continuous mixers are not manufactured by Ocrim because um, it's much better for us to focus on the batch mixer because basically it gives us the best results. Well, depending again on the types of flour mixes that we design and produce. I have to say that more and more often today, the continuous mix, so the continuous mixes, well, as far as our markets are concerned, is in very low demand.
Benissimo, grazie mille Fabio.
Okay, then Fabio, thank you so much. Plenty of very clear, exhaustive explanations, very comprehensive. You must have sent questions and we haven't had the time to answer, so please be patient. And if you have other questions, don't hesitate to use this email conferenceroom@ocrim.com. We will keep you updated for the next webinars. Okay, so once again, stay tuned. So have a look at our social networks. Fabio, thank you so much. Thank you to our technical director, and I hope I will meet you soon. Thank you so much for participating, for spending 1 hour with you. I hope to see you soon. Thank you so much for your patience. Once again, thank you. Enjoy the rest of the day. Thank you. Bye-bye.